Okay, so this is the pressure given the weight of a certain shoe size. And so what you find here is the weight on the x-axis. Okay, so there's the x-axis. That's weight in pounds. And so I gave you one point here. That point here is 100 pounds. Okay, I just made a mistake there. It's 100 pounds, comma, and then the other number is 9.1 pounds per square inch. So that's the y-axis. That's what that point is right there. So here's the y-axis right along here. That's pressure in psi's. Okay, when we look at this thing, what you see is it's pretty straight, pretty much lines up. And that also fits with the correlation. It's positive, linear association. It's very strong. In fact, it's whopping strong. It's basically 1. So I'm looking at that going, pretty good model. Then I looked for a pattern, and maybe some people say that's a pattern. I don't really know. It's somewhat random. And so if you don't like that, then you have to look for another model. I started looking for a model. I tried logarithms with the log of y, and I got a pattern in the residual like that. The correlation wasn't as good. I tried reciprocal of y, and I had it basically like that pattern, and the correlation wasn't even as good as that. And so I pretty much concluded there wasn't much else. There wasn't much. The patterns in the residual plots was worse. So remember the residual plot. There's like the x-axis units. There's your weight in pounds, and then the y-axis is your errors, your residuals, and those are the same units as pounds per square inch in this case. So we've got a model there. So if I'm going to erase some stuff here, and I'm going to use that model. I'm going to use that model over here. Okay. So I'm going to go with this model after looking at the other ones. I'm not going to show all the other stuff to you. Just it takes more time. So I know you want to be done. This is the last example. So we know that the predicted pressure is 0.092 times the weight in pounds, and then we're going to subtract 0.0041 from it. So if I write that again, the predicted pressure, 0.092, they want me to substitute, there's 0 here, they want me to substitute 175 pounds, and that's within our data. It's around here. There's 175 pounds in there. So it's in our data, so I'm comfortable making a prediction with this model. So I'm going to write that in there, 175 pounds. And so I end up getting, when I type that in, I get a pressure of 16.02 pounds per square inch. And I'm okay with that prediction. There are lots of ones you can try, but at some point you just sort of pick the best one. And you're not going to get in real life a correlation that high very often. So I'm going to take this, but I'm going to be, some people, I would like to get some more data. I can't really get much of a shape with 6 data points. It's got to be pretty obvious for a pattern, and this one doesn't seem like it was 6. If I might try get some data with shoe sizes in here and get a few more, and I might be better off then, or at least a little bit more comfortable with the model. So you don't always have to re-express it, but sometimes you check it.